All right. Hello everyone. Myself Narendra Singh Maurya. So guys, today we'll see Gate Aerospace 2024 aircraft performance solution, right? So here I have first question. Uh, as per the international standard atmosphere model, which one of the following options about density variation with increase in altitude in isothermal layer, right? In isothermal layer. So what is the isothermal layer? Basically two types of the uh, mainly what we are talking about, the airplane and aircraft, two layer we are studying basically, and that is the troposphere and stratosphere, right? So isothermal means constant temperature, right? Isothermal means constant temperature, and this constant temperature region or layer also called as stratosphere. Okay, what it is called? Stratosphere, right? And that region is what it is, from 11-kilometer altitude to somewhat 25-kilometer altitude. Okay, that region, it is varying also sometimes, but it is starting from 11-kilometer, that you need to remember. Right. So for the stratosphere, so as the name only, isothermal means constant temperature. So obviously in this region or in this layer, that temperature is what constant. There is no variation in temperature, but density and pressure variation will be there. And we know in the lectures we had seen, like as altitude is what increasing from the sea level, so pressure and density is what continuously decreasing, right? In even in troposphere as well as in stratosphere. But and if you talk about temperature, so obviously in troposphere it is decreasing linearly, but in stratosphere it becomes constant. But only pressure and density, that two properties, that two or pressure and temperature both are varying, and it is decreasing actually. Okay, so the options are here: increasing linearly, decreasing linearly, decreases, increases linearly, decreases linearly, decreases exponentially, remains constant. So as I mentioned, only temperature is what constant in isothermal layer. Pressure and pressure and density both are varying. So better we'll write the formula, and then we'll understand like it is linear variation or it is exponential, right? Let us see. So in stratosphere, if you check the pressure variation, directly formula I'm writing, because if I will derive then it will take time. So it is P2 by P1 is equal to exponent of G H1 minus H2 divided by R Ts. Okay, that exponent means it is the e to power G H1 minus H2 divided by RTS. And obviously that H1 and H2, it is, this is what troposphere. Okay, tropo, and this is what strato. Fine. So stratosphere started from 11 kilometers. So now your H1 is what here, and H2 is what here. Okay, always remember H1 will be 11 kilometer, from where stratosphere is what going to start, and H2 will be where, like it may be 15 kilometer, 16 kilometer, 17 kilometer, 20 kilometer, or 25 kilometer, maybe anything, right? But H1 must be 11 kilometers. So if you keep here, so okay, this is what pressure variation. Similarly, because temperature is what constant, temperature is constant, then if you apply P is equal to rho RT, that state equation, so temperature becomes constant. So obviously pressure are directly proportional to density, because R also you are considering constant characteristics gas constant. So pressure are directly proportional to density. So you can say whatever the formula of density, it will be the same, just like a pressure. So rho 2 by rho 1 is equal to P2 by P1. Similar is equal to the same formula, e to power G H1 minus H2 divided by R Ts. Ts is the temperature in stratosphere, means at 11 kilometer, whatever the temperature, it will be constant from 11 kilometer to 25 kilometer, right? Ts will be constant, G is gravitational acceleration, R characteristic gas constant, H1 and H2 both are altitude, right? So if you check the relation, so obviously density is what, first thing, this variation, density or pressure variation is what, exponentially. Now the question is what, increasing or decreasing? So as I mentioned already, it is decreasing, because once you are increasing the altitude, so this H2 value will be increasing, so this power becomes negative. So you can understand that rho2 and rho1, obviously this is the function of exponent. Okay, exponential variation will be there, and it is decreasing. So what is the correct answer? Decreases exponentially. This is the correct answer for this. All right. Right, now we'll go for the next question. Hope you understood this. Right, the question is, the airplane of mass 1000 kg in steady level flight with speed of 50 meter per second. The wing has an elliptical plane form with a span of 20 meter and plane form area 31.4 meter square. Assuming the density of air at that altitude to be 1 kg per meter cube and acceleration due to gravity to be 10 meter per second square, the induced drag on the wing is, right? So we'll see the solution for this problem. Okay, it's a simple one. Given, what are the given data? Obviously in exam you don't do all those things, solution, given data, and because I'm explaining here, so I have enough time to write each and everything. In exam directly you write the formula, write the at least data, and then immediately put in formula and you will get the answer. Okay, so mass, they have given mass of the airplane, they have given how much, 1000 kg, and at the same time they have given gravitational acceleration 10 meter per second square. So you just find out weight. Okay, because weight will be required, it is nothing but 1000, which is nothing but 10,000 Newton, right? Then speed of the aircraft, they have given v infinity, it is 50 meter per second. All right, and it says clearly here it is the elliptical platform, so that host wall efficiency small e, if you remember, for the elliptical platform it is E. Okay, this you need to remember, that's the reason they had given clearly here elliptical platform. Otherwise E value they will give to you. If they have given elliptical platform, means job is done, that means is host wall efficiency you have to take 1. I will tell you where this host wall efficiency will come. Next data they have given span. So span is what, suppose denoted by B, so it is given 20 meter. Plane form area, it is denoted by S, so it is given 31.4 meter square. Density, altitude, density of air at the altitude to be, so where the airplane is what flying, there the density is given how much, 1 kg per meter cube. Don't take sea level density blindly, here it is clearly mentioned. Okay, all right, done. So what they are asking, they are saying calculate induced drag, di, that is induced drag, you need to calculate. All right, now so we'll go for the solution of this problem. Now check, what is the induced drag here? It is di, similar formula just like a drag formula, half rho v square s into cd. If it is simple drag, then it is cd, because it's induced drag, hence you write cdi. Cdi means induced drag coefficient. That job is done. Okay, this is the formula. Okay, now we'll go for the calculation. So you know what is the induced drag coefficient, cdi. CDI is nothing but what? It's a KCl square. KCl square. Okay, and this K is nothing but 1 upon pi E AR. Okay, that each and everything you know, like what is AR? AR is obviously aspect ratio. So I can write here it is CL square divided by pi E AR. AR is nothing but aspect ratio, which is nothing but B square by S. Right, this AR is nothing but aspect ratio. All right. So ultimately CDI you got. Now you just keep here. So induced drag is nothing but what? Half rho V square S CDI, and here the CDI is nothing but, if you check, half rho V square S, and CDI obviously it is CL square divided by pi E. You can write B square and take S in numerator, so obviously S will come here. So overall, in short, what you can write, half rho V square S square CL square divided by pi E B square, right? Or you can write rho B square S square CL square divided by 2 pi E B square. Check CL they have given in the problem. No, they have not given. What you will do, because they have said clearly it is steady level flight. What is the mean of it? Steady level flight means lift is equal to weight they have given to us. What is the formula? Half rho V square S into CL. So what is the CL is nothing but 2 times of the weight rho V square S. This is the value of CL, because steady level, so lift is equal to weight, and weight they have given to us. Now write the DI formula. What is the DI? Check here. It's nothing but rho V square S square rho V square S square. I will take inside. This is 2 pi E B square, and in bracket it is CL square. So CL is nothing but 2W divided by rho V square S. This is the final thing. Now check in this, few things will be cancelled out. So rho V square S, okay, here it is square, so one rho V square S will be cancelled out. I think only one S will be there in numerator, right? Only one S will be there, or it is also going to cancel. Check. Rho V square S square, this is cancel it. So rho V square S square, this value. So what value you will have here, what value will be cancelled out, you check it. Now I think one row will be there in denominator, V square S, that will be cancelled out. So I can write here, it's 4W square divided by 2 pi E B square and rho. One row will be left, you please check it. Check the calculation. Ultimately what you got, 2W square divided by pi E B square rho. So now keep all the data, because now this becomes shorter. Now 2W square, what is the weight? Weight you have 10,000, right? So weight is 10,000 and it square divided by pi. What is the Ostwald efficiency for the elliptical wing? It is 1. Don't write this again, you just make it 1. It is 1. What is the span they have given? Span is 20 meter and S is 31.4. So it's 20, and S is cancelled out, I think. Yeah, S is cancelled out. Now, yeah, velocity, this is V square already. V, again, if you square it, then V to power 4 and V square. So 1 V square will be there. Sorry, you corrected here. So here V square will be there. Right. Now it becomes correct. So pi E and B square, right? Rho is given. Rho is given. It is 1 kg per meter cube, and then velocity. What is the velocity they have given? Velocity is V, 50 meter per second, right? So it is 50 meter per second. So 50 square. Do the calculation. If you calculate it, okay. So up to 2 digit, what we need to calculate? round off to 1 days. Okay, so here what I'm getting, it's approximate 63.66. If round off to 1 decimal place, so it becomes 63.7 Newton. This is the answer. So here I have written all the steps. That's the reason it took time. Otherwise, in exam you direct put in formula. Okay, I mean, don't write each and every steps. 63.7 Newton. Newton is already there, so 63.7 is your answer. Okay, and don't worry, reason will be given to you. I mean, your variation, answer variation, if it is little bit is there, then it will be acceptable. They will give the reason. Okay, like in this reason, your answer should be there. Done. Hope this problem is what you understood. Okay, now going for the next problem. They said, which of the following statement about absolute ceiling and service ceiling for a piston propeller aircraft is or correct? Okay, now options are here. These are the options. The altitude corresponding to absolute ceiling is lower than that for the service ceiling. The altitude corresponding to the absolute ceiling is higher than that for the service ceiling. At the service ceiling, the maximum rate of climb is 50 feet per minute. At the absolute ceiling, the power required for the cruise equals the maximum power available. This is the options. Okay, these are the options. Now, so question is, which of the following statement about service ceiling and absolute ceiling for the piston propeller aircraft is or correct? So you have to find which are the correct. So before going into this, I will few things I will tell you, like what is the service ceiling and absolute ceiling. Obviously it is already explained in like regular class, but just I want to remind you. That is the one thing. Second thing, last option, what is the for the ceiling, the power required for the cruise equal to the maximum power. What is the mean of it? That also I will tell you. Okay, then we have to go for the answer. Now, so yeah, ceiling is first of all, it's a altitude. Okay, service ceiling and absolute ceiling. So at the absolute ceiling, always remember it's a altitude where maximum rate of climb, I'm saying maximum rate of climb will be 0. That is called absolute ceiling. Okay. So now what about the service ceiling? So service ceiling, for the service ceiling, I have few things I will tell you. For the service ceiling, for both type of the engines, you please remember, because they are asking in exam. So for further, I mean, next exam, you, those who are watching, those who are going to prepare this time, at least for them also. So piston powered aircraft service ceiling. Okay, piston powered aircraft, and one is jet powered aircraft. So this value you need to remember. Service ceiling for the piston powered aircraft is 100 feet per minute, or it is in meter per second, 0.5 meter per second. This is for the piston powered. Next, jet powered. For this, what is the, this is what rate of climb. Okay, this is the rate of climb. And for the jet powered, it's a 500 feet per minute. Okay, and in meter per second, I think approximate 2.5 meter per second. That you need to remember. All right. This is also sometimes called combat ceiling. What it is called? Combat ceiling. So maximum rate of climb for the combat ceiling or this service ceiling is, and these values for the service ceiling, these values are the maximum value, rate of climb 100 feet per minute. This is the maximum value for the service ceiling. Now this is the one thing. Second thing, one more, I just want to give the graph also, so with the graph it will be more clear to you. See, this is the altitude, okay, and this is what the rate of climb, okay, this is what altitude. So here please concentrate. So okay, this is the R by C max, okay. So 2 points I'm taking. With the graph it will be more clear to you. This is 0.1, this is 0.2. So where maximum rate of climb becomes 0, that point called as absolute ceiling. So this is what absolute ceiling. Check this maximum rate of climb. This is the maximum rate of climb. Okay, basically this is the rate of climb x-axis, and maximum rate of climb is here. Here that maximum rate of climb becomes 0. So this point will be called absolute ceiling. And the second point, this is called service ceiling. I told you ceiling is the altitude. This is the one thing. Okay. One more thing I just want to tell you. What is that? Rate of climb. So already in my lectures I had explained rate of climb is the total power, change of power divided by weight. That's the reason it is called a specific power, okay, this rate of climb. So what is the delta P? Delta P is the power available minus power required by weight. This is what rate of climb, RC. It is also denoted by RC. Now we'll go for the options, given options, right? Now check here. See, all those things why I have explained, because it is required. Now once you know this, then all the 4 options with you, and you can find what is the correct answer. What they said, the altitude corresponding to absolute ceiling is lower than that for the service ceiling. Check, absolute ceiling is lower than service ceiling. No, absolute ceiling is higher than service ceiling. Yes or no? So absolute ceiling is not lower, hence this part is wrong. Altitude corresponding to absolute ceiling is higher than the service ceiling. Yes, absolute ceiling is higher than the service ceiling. So option 2 is correct. Because it is MSQ, is or are means more than one option is also correct. So we'll go for the third option. At the service ceiling, the maximum rate of climb is 50 feet per minute. This 50 feet per minute for what? For what type of engine? Check, piston propeller aircraft or piston powered. What is the piston powered rate of climb maximum? It is 100 feet per minute. But what they have given? They have given 50 feet per minute. Means this is also wrong. All right. Option D. At the absolute ceiling, the power required for the cruise equals the maximum power. Yes. Why? Because what is the delta rate of climb? Rate of climb is power available minus power required by weight. And if power available, maximum power available and required power is equal, then what will be the rate of climb? At that point, that rate of climb will be 0. Why? Because power available and power required becomes equal, then it is 0. In which case rate of climb, maximum rate of climb becomes 0. What is the first option? Only I told you, absolute ceiling. This for this, and this graph also is what saying, for the absolute ceiling maximum rate of climb becomes 0. So check the option here, absolute ceiling, obviously rate of climb will be 0. So, and when it will be 0? When power available and power required becomes equal. And yes, so this option D is also correct. So what is the correct option here? B and C. B and C is the correct option. Okay, correct option is B and C. All right, hope you understood this. See, for this type of question, hardly 1 or 1.5 minutes should take not more than that, max 2 minutes, not more than that. Here I am taking 10 minutes. Why? Because I am explaining the extra things here, okay, so that you can understand and you can recall or you can relate with the your subjects, okay. I mean, what you have learned, you can relate that, right? Done. Now we'll go for the next one. Listen, an aircraft moving at 4 km altitude above mean sea level at a Mach number of 0.2. The ratio of equivalent airspeed to true airspeed, okay, is the density of air at mean sea level and at 4 km altitude is given, right? So you just say for this problem, this is what sea level, this aircraft is what flying here, right? What is the altitude? Altitude is 4 km altitude, right? And this is what sea level, sea level, SL for sea level. Now check the problem here. What given data, based on that we have to solve. This aircraft is what flying with Mach 0.2, and here where 4 km aircraft is at flying, there the density they have given 4 km altitude, the density is 0.8. So I have to say this is rho, and it is nothing but 0.819 kg per meter cube. Secondary, the sea level density what we have, it is 1.225 kg per meter cube. Where the aircraft is what flying at that altitude, what if you take the same density, then this speed will be called true air speed. And for the same aircraft which is flying at 4 km altitude, but if you take density at sea level density, if you take sea level density, then that speed will be equivalent air speed. That already I have discussed in my regular lectures, right? Simple. They are saying you just find out the ratio of equivalent air speed and true air speed. So I will write what is the dynamic pressure for both reference point of view. You just compare it. So it is nothing but first you will write for the true air speed. So what is the dynamic pressure? That there, half rho v square. This is for true air speed. So true air speed and density will be at the same altitude at 4 km. This pressure, dynamic pressure, must be equal to half rho v square. Now you are taking equivalent air speed, hence your density will be sea level density, right? Now just find out what ratio they are saying. Equivalent to true air speed. So equivalent to true air speed, what is VEAS divided by true air speed? Check. It is nothing but rho divided by rho infinity in root. What is the value? 0.819. 1.225. All right. If you calculate this value, where is my calculator? So this is nothing but 0.819 divided by 1.225. Take root of it. It's 0.817. Check. They are saying round up to decimal. So 8, what is the value? 8176 I have. If you round up to 2 digits, so it is 0.82. What is your answer here? It is 0.82. This is the answer. All right. Now moving ahead for next question. All right. Airplane experiences a net vertical ground reaction of 15,000 Newton, okay, during landing. So during landing, all right, the weight of airplane is 10,000 Newton. It's 10,000 Newton. And once it is during landing condition, the ground reaction, vertical ground reaction, this load is nothing but 15,000 Newton. The landing vertical load factor, okay? What is the vertical load factor? It is N is equal to lift by weight generally once it is flying, steady level condition. Not steady level, you can say if it is flying condition, better to say. If it is flying condition, then lift by weight. But once it is landing condition, so if they ask what is the vertical load factor, so they have defined also. It is defined like landing vertical load factor is defined as the ratio of inertial load, okay, inertial load to weight of aircraft. So what is the inertial load? So ground reaction force, and only two data they have given. So here the inertial load, you can say that will be the vertical ground reaction force, and it is nothing but 15,000, okay, divided by the weight is given 10,000. How much? It's, I think, 1.5. I think this is the correct answer. 1.5. All right. Right. Okay. This is the next question. What they said: which one of the following figures represents drag polar of a general aviation aircraft? So see options. What is the basically drag polar? It's a CL versus CD graph. CL versus CD graph. Okay. And here you have to show the, even though you know the drag polar equation also. What is the drag polar equation? If you remember, CD is nothing but that parasite drag plus induced drag. This is drag polar equation. Many times you have seen CD is equal to CD naught plus CDI induced drag is nothing but KCL square. So here, see, this x-axis is the CD. So whatever the this value, okay, this value is nothing but CD naught, and you draw the tangent of this, okay. So and obviously the tangent here also. So this value is nothing but CDI. See why I'm not going for others, because all are wrong. See, it's a simple direct question. Okay. So option A is correct. After seeing only within second, you can say this one is correct, because this is the copy paste question direct from the book. No. So I'm just explaining CD and CL. So this value is CD naught, and this is nothing but CDI. So what is the total drag CD? So total drag CD, drag coefficient actually. So total drag coefficient is nothing but parasite drag. This is the parasite drag, and this is the induced drag. Okay. So remember, this is the drag polar equation. Yeah, I mean, this is the figure for the drag polar, where both, I mean, parasite drag and induced drag is what combining. So this is the option A is correct. Only option A is correct for this question. Not going for others because it is not correct. Now we'll go for the next question. This is the next question. See, the flowing of the following statements about a general aviation aircraft. Okay, general aviation aircraft while operating at point Q in Venn diagram. What is the Q? Okay, this Q. Okay, this is positive limit load factor and this is the positive ultimate load factor. This is velocity and this y-axis is the load factor. So velocity versus n. That's the reason it is called Venn diagram. Velocity versus load factor. Okay. Now check the options. So the aircraft is operating at CL max. Okay. The aircraft has the smallest turn radius. The aircraft is what flying with minimum drag. The aircraft has the highest turn rate. Right. Now, so before going to the options, I just want to tell you this point Q. Point Q is sometimes it is called corner velocity. What it is called? Corner velocity, right? Good. Now, the limit load factor and maximum load factor they have given to us. In between, positive ultimate load factor and positive limit load factor they have given. Ultimate load factor means that's maximum that can sustain. Otherwise, there will be the failure, structural failure, right? This side it is the aerodynamics failure. This is what aerodynamics stall means aerodynamics failure. This side it is structural failure. If you go beyond this, structural failure will come. And obviously this is the propulsive limit because velocity term is there, propulsive limit, no? Means beyond this particular velocity that is the maximum thrust that engine can produce, and beyond this value it is not possible because that engine will not produce that much amount of the thrust, or you can see engine will be filled. Okay, so that's the reason it is sometimes called envelope, flying envelope or flight envelope. Okay, means in this region aircraft, they are saying in this region the aircraft is what safe here. Okay, these are the reasons. Now, if you talk about point Q, so it's a corner velocity, and if you go for the options, so this corner velocity or corner speed, I just want to write the formula. So, what is the formula for the corner speed? I just want to explain this. Corner speed or velocity, it's called Vs, and sometimes it is also stall speed. So it is 2W by rho s CL max because it's a stall speed. So obviously Vs is what inversely proportional to root of CL max. So check one option. The aircraft is operating at the CL max. Yes, because point Q is the corner speed which relates to the stall speed, and stall speed, it is operating at the maximum CL max. So this option is 100% correct. Right? Point Q, na? Yeah. Now rest they are talking about the smallest turn radius. So radius and turn rate both cases, and minimum drag, three options we have. Check because it is a MSQ question, multiple select question. Is are true, no? That means more than one option also correct. So don't think okay option one is correct then you just leave. No, read the problem properly, read the questions. It is MSQ or MCQ means multiple choice question, means only one option will be correct. MSQ means multiple select question, means more than one option will be correct. That you need to remember in exam, right? Now coming to the next option, aircraft has the smallest turn radius. So we'll try to define this, how turn radius will come into picture. Okay, that is the one thing. Now the load factor, that load factor lift by weight. This is the load factor, right? So if you write this value, so it is nothing but half rho V square S into CL max. Because at point Q, what is the lift coefficient? That aircraft will be operating at CL max. So lift formula, CL, instead of CL, it will be CL max divided by weight. You can say half rho V square CL max divided by W by S. W by S is nothing but wing loading. Okay. So here you can understand N is directly proportional to CL max. Means if you say load factor is the function of CL max. Okay. Once the aircraft is what operating at point Q, and the another way you can say the aircraft is what operating with the maximum CL max, maximum lift coefficient. So obviously load factor is also the function of maximum lift coefficient. So that will define the turn radius and turn rate, minimum drag. We'll see what is the minimum drag mean here. Okay. Coming to the turning condition, turning flight, you know, turn radius. Okay. What is the turn radius in turning flight? Turn radius, that is R. If you recall it, V square divided by G N square minus 1, right? N square minus 1. Now coming to the C, it is the function of CL max. So N directly proportional to CL max means that load factor, because lift coefficient is maximum, hence this load factor will also be maximum. So coming to the radius turn, if here the load factor, again I will write in here, this load factor at point Q is what maximum. If this value is what maximum, then this radius, turn radius will be what? Turn radius will be is minimum at point Q. Everything we are talking about point Q, a minimum or a smallest. Smallest. We'll go for the aircraft has the smallest turn radius. This is also correct. Aircraft is flying with minimum drag. So we'll hold this option C. We'll go for the option D. The aircraft has the highest turn rate, because here also we have a turning flight. Here also we'll have turning flight. So first we'll write the turn rate formula. What is the turn rate formula? That is omega. What is the turn rate formula? Omega, if you remember, so at point Q, what is the load factor? It is maximum. So load factor is maximum, hence this turn rate will also be maximum. It means highest turn rate at point Q. Highest turn rate. And guys, please remember this directly. I'm not writing this formula. These are the turning flight. If you go turning flight, so all the formula I had discussed. Check the notes. Here also this is in turning flight. No? Okay. So highest turn rate at point Q. Okay. So this aircraft has the highest turn rate. This option is also correct. Now coming to the option C. I told you, yes, hold on for option C. Aircraft is what? Flying with minimum drag. See, for the minimum drag condition, it is not like a for others. I mean, that was related with the load factor. If it is flying with the minimum drag condition, then the effect of load factor, if maximum load factor is there, then it will be the minimum drag. That condition will not be satisfied. Okay. So what option is wrong here? That option C. So this is not correct. That aircraft is flying with minimum drag. This option is not correct. Rest all three are the correct options. Right? Thank you.